Assalamualaikum and hi. Very good morning to everyone. So my name is Amirul Imran bin Mohd Sopian 18002226, and today I'll present about control volume for my lab session MEB2043 fluid mechanics. Alright. So for introduction to control volume. So the moving fluid in natural or artificial systems may exert forces on object in contact with it. So to analyze fluid motion, a finite region of the fluids, which is the control volume, is usually selected, and the gross effect of the flow, such as its force or torque on an object, is determined by calculating the net mass rate that flows into and out of the control volume. These forces can be determined, as in solid mechanics using Newton's second law, by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum coefficient. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery. To explain further what I just said earlier, so we will conduct an experiment. The objective of this experiment is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface. Moving on, so this is the list of apparatus that we need to conduct this experiment. So number one is F1 to 10 hydraulic sponge. Number two is stopwatch. Number three is weight pen, and then spring, nail screw, inlet pipe, level gauge, target plate, nozzle, and inlet pipe. So here is this how we set up the apparatus. So you can see from below is adjustable feet, and then we have inlet pipe, and then we have nozzle here, and then we have target plate, nail screw, spring here, weight pen, and level gauge. So this is how we set up to conduct the experiment. Moving on to the methodology of the experiment. Number one, remove the top plate and the transparent cylinder from the equipment, and then we need to replace the cylinder and screw the deflector onto the end of shaft. Connect the inlet tube to quick release connector, and then replace the top plate on the transparent cylinder, and then using the spirit level attached to the top plate, level the cylinder. Replace the 3 nail nuts and tighten in sequence. Number 7, we need to remove the top plate and the transparent cylinder from the equipment. Ensure that the vertical shaft is free to move and supported by the spring. Adjust the height of the level gauge until it aligns with the datum line on the weight pen. Place a mass of 50 grams and turn the pump. Open the bench valve and allow water to impinge upon the target. Measure the flow rate using a volumetric tank. And lastly, repeat the step by adding 50 grams incrementally until it reaches 500 grams. Then repeat using 2 flow detectors. Moving on to results and calculation. So this is the formula of the experiment to be used, and then this is our table to get all the results. Alright, so let's start with formula first. You can see first of all, the velocity of the water V leaving the nozzle with the cross-sectional area can be calculated by V equal to Q over A. And then we apply the momentum equation to a control volume. We can get Fy equal to rho Q V cos theta plus 1. We can get this equation. So whereby Fy is force exerted by the deflector on the fluid, and then rho is fluid density, theta is 180 minus alpha, where alpha is the flow detection angle. Alright, so this is the example of flow direction angle for flat and hemispherical deflector. So we need to measure the angle, and then we insert in the formula. So since Fy equal to W, we also can write W as W equal to rho QV cos theta plus 1. And then we know Q equal to VA. So we can replace the Q in the equation. So our new equation will be W equal to rho A V square cos theta plus 1. Alright, so the last that will be used, equation that will be used is theoretical slope. Theoretical slope can be determined using the formula S equal to rho A cos theta plus 1. So we will plot the graph for W against V square. Alright, so this is our result table. So we need to plot all this data, and then we will make a graph W against V2. So and then we can get those data. So that's all for results and calculation. Right. So last but not least, these are the conclusion of the experiment. So number one, the objective to investigate reaction forces produced by the change in momentum of a fluid flow when a jet water strikes a flat place has been achieved. Number two, the external forces include the component of the weight of the fluid and of the forces exerted externally upon the boundary surface of the control volume. And lastly, referring to the momentum equation, force must be equal to the rate of change of momentum of the jet in the same direction. So that's all for today. Thank you for watching.